In this video, we are going to discuss about power amplifiers. A power amplifier is an amplifier which is able to provide a large number of power to the load, such as loudspeaker. So basically, all the electronic systems which requires a large number of power in order to supply to the load. So it is employed at the last stage of the electronic systems. For example, it is used in microphones, loudspeaker. This power amplifier is also known as an audio amplifier. So basically, this power amplifier will, comes under the category of large signal amplifiers. So the power amplifier which does not actually amplify the power. It takes the output. It takes the input from the DC power supply and it connected to the output circuit. That is, it converts. It takes the output from the DC to. It takes the input from the DC and it gives us a AC signal power. That is a power which is fed to the load. So the large signal amplifiers, the term which comes because these amplifiers use a large part of their AC load line for the operation, whereas in small signal amplifier it use only the 10% of their AC load line for the operation. So the small signal amplifier is called as a voltage amplifiers. Okay. So basically, this power amplifier classified as class A, then class B, then class C, then class D, then class AB and class C. So let us discuss first of all the class A amplifier. So the class A amplifier, there are two types. One is RC direct coupled. One is direct coupled. Another one is transformer coupled. So first let us discuss about direct coupled. Class A amplifiers. So class A amplifier, it is an amplifier in which the transistor bias and the amplitude of the input signal is such a way that the output current flows for the complete cycle, that is 360 degree of the input signal. So let us discuss the circuit diagram of direct coupled. So here we are using a common emitter class A amplifiers. So basically, if you see the difference between the earlier circuit and the small signal version is the signal handled by the power amplifier circuit is in the range of volts, whereas in power transistor it is capable of operating in the range of few watts. So let us discuss the circuit diagram. So this is a coupling capacitor, and you are taking the output at here. So as I said earlier, we need to plot the curve versus VCE versus IC. So this is your output, VCE collected to emitter, and IC is the current which is flowing here. So we need to find the value of by seeing this in this direction. We can write VCC equal to ICRL plus VCE. So when VCE is equal to 0, I can write VCC is equal to ICRL, where IC is equal to VCC by RL. So this is the value. So this is a value where VC is equal to 0. So IC is VCC by RL. Second, when I substitute IC is equal to 0 and the equation 1, this is the equation 2. So VCC is equal to VCE. So that is this point. So at this point VCC is equal to VCE. So it can draw the line. So this is nothing but DC load line. So this is the slope. So the slope value is nothing but minus 1 divided by R. So we know the curve for common emitter amplifier. So sorry. So this is a value we are varying with respect to the input current, which is nothing but IB. Okay. So here this value is nothing but I max, and this is I minimum, and similarly this is V minimum, and this is V max. And we know that the V max value is nothing but VCC, and V minimum value is 0, and I minimum value is also 0. And suppose if this is ICQ, means what is I max? I max is nothing but 2 ICQ, and we know that this value is nothing but IM, right? So I can write PDC. PDC is equal to VCC into ICQ, and PAC. AC is equal to VRMS into IRMS. So this I can write it as VM by root 2 into IM by root 2. So this is nothing but IM divided by 2. So I can write this one as so suppose this is VM, means this is nothing but 2 VM. So similarly, this is I can write it as 2Im. Okay. So this I can write it as if I multiply by 2, 2 Vm by 2 into 2 into 2 Im into 2. So I can write like this. So this is nothing but 4 Vm Im divided by 8. So this 2 Im I can write it as Vmax minus Vmin. Similarly to this 2 Im I can write it as I max minus I minimum by 8. 2 Vm I can write it as Vmax by V. So substitute the value. Vmax is nothing but Vcc and the V minimum is 0. Similarly this I max is nothing but 2 ICQ minus 0 divided by 8. So I can write PAC is equal to VCC ICQ divided by 4. So we know that the efficiency formula is equal to PAC divided by PDC. So I substitute this value. What is PAC? PAC is VCC ICQ divided by 4 by VCC into ICQ. So this is nothing but 1 divided by 4 into 100. So this is nothing but 25%. So the efficiency is 25% for class A series where that is direct coupled class A amplifiers. So we can determine the maximum power dissipation. So what is maximum power dissipation? Maximum power dissipation. The formula is PD is equal to PDC minus PAC. So the maximum power take place when the AC input signal is 0. So the entire power is dissipated in form of heat. So I can write PD max is equal to VCC into ICQ. So let us discuss the advantage of this circuit. So that first advantage is the circuit is very simple because we are using very less component, and it is cheaper because the load is directly connected to the collector. So it is very cheaper, and the less number of components is used in the circuit. Next one is disadvantages. Since we are connecting the we are directly connecting the load to the collector, the power, lot of power is wasted. So that is why the efficiency is very low, right? So the efficiency is very poor. In terms of 25%, and the power dissipation is very high. Therefore it requires a heat sink. So that's all about the video. Thank you very much.